Well, the last thing in Chapter 2 that we need to talk about is a concept called density. All right. Now, back a long time ago, when chemistry was first getting going, a way to characterize something was its density. All right. Now, we have a lot better methods now. We have computer-generated things like NMR, FTIR, we have GCFTIR, GCMS. I mean, there's just all kinds of atomic absorption, computerized things. But back in the day, chemists used to use density quite frequently, and here's why. Because every substance has kind of a unique density, all right? And it is a property that does not depend on how much of the substance you have. In other words, the density of water is 1 gram per milliliter. And it does not matter if you have a half a milliliter or 55 gallons of water. The density of water is 1 gram per milliliter. All right? Because you can take a mass divided by a volume, all right? And that's what density is. Now, density is something that is temperature dependent. In other words, the density of materials change based on their temperature. So I told you the density of water was 1. Well, that's not entirely true. Okay? The density of water will change ever so slightly, 0.9986, 0.9985, what have you, based on its temperature. Okay? But it's more or less 1. Okay, so basically, the hotter something gets, would you think it gets more dense or less dense as a general everyday stuff? Less dense, right? Because a hot air balloon, if you heat up the air gets less dense and rises. Okay? Same way with water. Where do you find your hottest water? Toward the surface. Okay? As you go deeper, it's where the colder water lays, generally. Okay? Now, that's your density. Now, there is also something that's called specific gravity. Okay? And what specific gravity is the density of the substance divided by the density of water. Okay? And it is a unitless number. Now, one of the places you would see this in just an everyday thing is like if you went to the doctor and they give you a urinalysis. One of the first things up there is the specific gravity of your urine. Now, what would you think the specific gravity of your urine would be close to? 1, right? Because it's water. Okay? Now, I mean, certainly there's other things in there naturally, but mostly it's water. Okay? Now, the density of water, remember I told you, was in this classroom here, we can call it 1. Technically, it's not. This number may be 0.998. All right? But roughly, it's 1. Okay, so what does that mean? The specific gravity is approximately equal to the density of the substance at room temperature. So when it says that the specific gravity of urine is 1.005, all right, that's more or less the density of your urine. It is not, I mean, it can be sharpshooted. That's not exactly what it is, but it's more or less that, right? Because you take the temperature of your urine and plug in whatever number they need to put in there. All right. So are we good with density? Okay. So first off, mass. That's simple. These days we got balances everywhere. You basically stick the thing on top of the balance and you get a mass. Now, how do you get a volume? Measure it how? Measure the size. That would be a wonderful idea, especially if you had a regularly shaped object. Something like a sphere, a cylinder, a rectangle, a box, a cube, something that had a geometrical everyday formula. All right? And you simply look up, how do you find the volume of a box? Well, it's length times width times height. Pull out a ruler and do it. Now, another way to find the volume of something is by using Archimedes' principle. Okay, so for an example, let's say that this is a graduated cylinder here that's got 25 milliliters of water in it. Okay, and let's say I have some little thing like this that's made out of metal. Well, how would you get the volume of that? Well, I guess if you had a pair of micrometers, you know, you could divide this up and approximate that kind of looks like a sphere, and you know, you could get close. Or you could take this irregularly shaped thing and put in the bottom of this. And if you did that, what would you expect the water level to do? To rise, right? So maybe it went from 25, I don't even know, to 27 milliliters. All right. So what would that mean? What would the volume of this thing be then? 2 milliliters, see? So you got that right there. As a matter of fact, in lab tomorrow, that would be the type of thing you're going to be doing. All right. You're going to take an irregularly shaped thing. You can even take a regularly shaped thing. Drop it down in the water. You can watch the water height change, and that's your volume. Then you can go next door, and we'll show you how to use the balances and where they're at and get the measurement, and you can find the density. Now, if you had a density of metal, would you predict it would be less than 1 or greater than 1? Greater than 1, right? Because the metal's going to sink. Now, what about acetone, which is fingernail polish remover? We've got that in there. If you're taking the density of that, what would you expect? Be less than 1. Most organics, I did not say all, okay, so you have to start listening to my words here. Most organics float, okay? So if you've got 22 gallons of gas in your truck out there, and then you put 22 gallons of water in the back, which one weighs the most? The water, all right, because the gas is less dense than water, okay. Now there are certainly organics out there that will sink. One of the very dangerous ones, carbon tetrachloride. Put that in the river, straight to the bottom it goes, all right, but that's unusual. Most of the time organics will float, okay. All right, are we good with density? Yes, no, maybe? All right, should we work some problems? Let's try a couple, okay. Let's try number 75 and 78. Okay, so page 45, number 75 and 78, and let's get together in a group, work these for 3 or 4 minutes, and I'll get back with you.